All right, we'll go ahead and get started. So good afternoon. Hope everybody's having a good, solid day one here at Ignite. So it's a real pleasure to be here. The team's been working incredibly hard on building what we believe is one of the most comprehensive and competitive data platforms in the industry. So today we're going to take a first public look at SQL Server 2016, as well as Azure SQL Data Warehouse. So I hope in this session we can show you what's possible with data and ultimately inspire you on what you can do as we go ahead. So we'll go ahead and jump right into it here. So when you think about, as Satya noted in the keynote this morning, he talked about industry transformation, and he gave several examples of it with Real Madrid, Alaska Airlines, Fujitsu, etc. What's at the center of that transformation is data. That's the fundamental truth behind all of that. And companies who can embrace data are going to be far more competitive than companies that don't. I think it's as simple as that. So when you think about a data-centric application or a data-centric company, one that embraces data, it really does push on this other aspect that says if you're going to be data-centric, you also need a consistent data lifecycle. In my experience, I don't know that one exists without the other. If you think about the way we think about this consistent data lifecycle sort of fits into these three parts. The first part on the bottom of this circle in blue is capture and manage, and this really speaks to collecting data in different types. It could be relational, documents, streams, unstructured information. And then once you've collected that data, the second part of this life cycle is how do you transform and analyze it? This is where a lot of predictive analytics come into place. And then the third part of that consistent life cycle is really around visualization. You know, users being able to see information. It could be through a nice visual aid. And then decide on things. Sometimes we talk about an insight is worth a penny and a decision is worth $1. This is one place where that really comes together in that life cycle. Now, when you really sort of step back and look at our platform as a whole in those three dimensions, and we talk about apps or companies that are embracing data, I'll just sort of give you an example of applications and what we see and what they're doing truly to embrace data and what that means from a user experience. On capture and manage, you'll have a ticketing system, for example. That ticketing system could use something like Azure SQL Database. They could use SQL Server. This is where a lot of transactions will happen. Up in the cloud, it's all about big, giant scale, being able to scale up and down very quickly. Same is true for on-premise. An application may decide, a ticketing application may decide that it wants to capture user ratings. So when somebody comes to buy a new ticket, they can at least see what others have said. In that case, you might use something like DocumentDB. It's really quick. It's very iterative. You may have an application that wants to deal with real-time streaming. So in this new social environment, people are tweeting. You could use something like HD Insight to capture those tweets and incorporate that back into your application. In this middle tier, once you have all of this data, a lot of predictive analytics come into play here. So if you think of something like I have data and I want to do shopping cart analysis, I want to do predictive analytics on where credit risk may be, etc. Across that middle tier is where there is huge investment in the industry. And what you can do with this information, with the data, is incredible. And then finally in that top tier, this is where things like Power BI, companies that want to make very, very nice dashboards that are beautiful in some sense, but ultimately help people make sense of all this information very quickly. To what I think is one of the coolest things on the top board here is visualizing things is one thing. But when you can ask natural language question to data and get a response back, it's incredible how quickly people will go from insights to decisions. Now, before we look at SQL Server 2016, I just want to spend a couple of minutes on this slide. Why? Because we keep talking about cloud first in the industry. But I really want to sort of give you a behind-the-scenes view on what Cloud First has done to how we build software. Sometimes when I give this talk, I honestly say that if there was one slide I could talk to you about, it'd be this one, because this whole Cloud First notion has completely changed how we build software. So I'll give you the four sort of short stories here. The cloud-first direction in our engineering team means basically this. An engineer comes to work, they have an idea, they fail as fast as possible. That's good. Why? Because you want to fail every single idea that isn't going to work as fast as you possibly can so you can get to the discovery. In a box world, doesn't really work like that. If you guys remember of how we've worked together in the past in a non-cloud first world, we'd come up with a design, we'd package it, this whole life cycle would go for some period of time, we would give you those bits, you would try those bits out, we would sort of learn from each other, and what we can do in the matter of hours and days in the cloud, in the old world it would take us weeks and months. So speed is incredible in the context of cloud first and from an engineering perspective. The second aspect of cloud first is agility. What do I mean by agility? Well, if you and I were sitting in a room together and we came up with an idea, we'd sketch it out on the whiteboard, we'd try that design out, we'd deploy it into Azure, and then once we have it in Azure, we can now quickly start to change designs and further shape scenarios. If we were working on something like role-level security together, in the past we would have spent a lot of time on paper, and then we would have spent a lot of time on one of our desktops. In this new environment, we're in the cloud and we're moving quickly and we can iterate designs. So the agility in the cloud is amazing. That leads to the third fundamental thing is proven. What do I mean by proven? So you and I have been working together, we came up with a design, we've been iterating on it incredibly fast. But here comes one of the coolest things about the cloud. When we hit deploy, that's worldwide deployment instantly. So when you think of Azure, you and I are working together as software developers, and we get an instant worldwide deployment of something like an HA feature. That's awesome. Why? Because I want to see that thing break as fast as possible at a global scale. In the old world, not possible. We would have walked down a hall together. I would have said, hey, there's 30 or 40 servers in that lab. Let's try it out there. And then when we would hand it over to you, then as time went on, we would get this sort of global deployment. In the cloud, we can do this in a matter of minutes. It's awesome. So here's the last thing about cloud first. Feedback. In the previous world, feedback really, honestly, worked something like this. We'd give you a box product, you'd deploy it, we'd bump into each other at a show like this, you would email us if we had exchanged our contact info. There would have been a number of other forums where we might have been able to talk to each other. Just last week, this is how it works in the cloud, totally different. Just last week at Build, we announced some new capability in Azure SQL Database. The amount of feedback we got in one day, actually 2 or 3 hours, huge. You're talking hundreds of people. Here's the next best thing about the cloud. That feedback is very expressive in terms of what people do and don't like. Awesome signal for us in the engineering team. We can respond to it quickly. So when you sort of put those 4 things together, cloud first is an industry term, but I really wanted to give you insight. It has completely changed how we build software. And with this cloud first mantra, which basically means everything we build is built in the cloud first, then we bring it down to SQL 16, cloud first is the reason SQL Server 16 we think is one of the best releases we have built to date. Because of that speed, that agility, role-level security, we introduced it to Azure SQL Database. By the time that comes down to SQL Server 2016, it will have been running at a global scale for many, many, many months. So now let's get into SQL Server 2016. When we talk to customers about 2016, we have one of these 3 conversations. We'll sort of go from left to right. First conversation we usually have is around mission critical. This is where things like in-memory OLTP come into play, and others, always on. Deeper insights, this is where we're talking about Power BI and things in that nature, reporting services. And then finally, hyperscale cloud. We heard Satya talk about StretchDB. I can't wait to get to this demo to show this to you live. This is really where that cloud connection comes back to the box. So that's sort of the framework that we'll use to look at some of the features that we're building. So let's start in mission critical. So the first big bet, what I'll do here is I'll basically show you big bets followed with demo, and then we'll look at a summary, sort of move through those chapters. But the first big bet for us is in memory. How many people here are familiar with in-memory OLTP and SQL Server 2014? All right, good. A good number of us. Awesome. So then you'll grok this quickly. So here's what we've heard from customers. I have, for example, a transaction system. I need huge fast throughput. My DBAs have done everything they can to make that throughput as fast as they can, but we're going to in-memory optimize that table. Now all of a sudden we get greater throughput. Next thing we need to do is ETL data into a data warehouse. This is where column store comes into play. Column store will help us do some sort of analytics on top of that data. We all know that ETL process sometimes can go fast, sometimes it can take a day. When it takes 24 hours, you know when that's not good? It's if we're trying to do something like fraud detection. You know, think about how important it is for businesses to deal with signals in real time. In this particular picture, we might discover fraud detection a day too late. So that really pushes on how do we what can we do in memory to bring both rows and columns closer together so everything is running in memory and we have a more real-time experience. So let me show you what we're doing here in 2016. So we're basically combining rows and columns. We refer to that as operational analytics, and here's how it works. Effectively, what you'll have is an in-memory table. You can run transactions through the system. On that in-memory table, you can put a column store index, and that will allow you to do analytics on that table in real time, all in memory. And then when you, awesome. All right, we're off to a good start, Rohan. I love this one, though. And it's not just about fraud detection. With some of that applause, Rohan, come on up. Let's just get right to the demo. Okay, so Mr. Kumar is going to join us here. Let's take a look at our first demo for operational analytics. Right. I'll switch you over to 2
this is
or
number
1.
Yeah.
Got it.
So while Sean sort of does that, thanks, Sean. Hello, everyone. Let me introduce you to this company, Fabricam. The company is called Fabricam. Fabricam runs a very extremely popular online pharmacy which sells drugs worldwide. They very recently started selling this new groundbreaking drug called Fabricam Biotics, whose sales have gone viral worldwide. Now, whenever they actually start selling a new drug, they track 2 measures very carefully. One of them is online sales, like how are the sales going on across the world. And the second thing, since it's a new drug, the very first time they've introduced it, they track customer sentiment, especially the negative customer sentiment. Now, given the size and scale of growth of their customer base, it has become very, very critical for them to track these 2 measures in a real-time manner. Now, SQL Server 2016 allows them to reach this goal. By building on the operational analytics feature of SQL Server 2016, just like Sean just explained, they're able to run their operational workloads, which track their online sales and the customer sentiment in real time, while simultaneously allowing analytics queries to be run for anomaly detection. Now, what do I mean by anomaly detection? So anomaly detection is when you start seeing a little shift in trends, which seems like it's sort of deviating from the normal based on the past analysis of data.
Got it.
Right? Now, the key here to achieve real-time performance, as Sean just explained, is that the need to do ETL to actually take the data from your operational store into a new data warehouse for analytics has to be eliminated. Right? That's exactly what they've done. They've taken their analytic queries and they're running it directly against the table that actually stores their OLTP operational data. And the big news here, essentially, is that Fabricam was able to accomplish this. Guess what? With close to 0 impact on their OLTP performance right on that table. That is key. Now, what you see here, actually on the screens, is a live operational dashboard that Terry Adams, who's the chief pharmacist of Fabricam, monitors regularly. Right? There are 2 charts, right? One is actually tracking, the sales of the drug, and the other is tracking the customer sentiment. Both of these charts are actually backed by very highly performant and scalable tables that have been built on operational analytics feature in SQL Server 2016. This is all live, right? And if you take a look at the query volume and the sub-second response times, that actually proves the point, that how this feature is sort of helping them. Now, as you can see in the chart that's actually live and it's showing you the prescription activities, the sales of this, as expected, have gone through the roof, right? I mean, significant amount of sales. And what Terry notices on the negative sentiment chart is that it's a little higher in the recent, like the recent few minutes. It sort of spiked up higher than what he expects it to be, right? The good news, though, is that he was able to detect this anomaly in real time. Now, he needs to do further investigation to figure out whether this anomaly is due to a legitimate, genuine scenario, or is there some sort of fraud going on. And the reason he's concerned about this is because based on his past experience, he's actually seen that whenever a popular drug like this comes out, right, in certain parts of the world, just given the demand, they try to sort of add more like water pills and sugar pills, just given the demand, right? So let's see what he does next. Let's just dig into the analytics part of this, right? As soon as he digs that, you can see there's so many patients who are at risk, they're complaining about it, and very soon he's able to figure out that in the western region that they track, the negative sentiment has gone up.
Right. So if we pause here for a minute, basically the page previous, we see all these transactions coming through the system. Right. People are ordering this new, what'd you call it? A super fancy
Fabricam Biotics.
Yeah, that
it's
thing.
Easy, man.
Right, and that's coming into the system. We run it in memory just so we get transactions fast. But a real problem in the world is, especially when a drug takes off, and it couldn't be from a global perspective, as fraud happens. What do I mean by that? Sugar pills get introduced into the system.
Exactly.
And I think this thing's basically saying, hey, there's some negative sentiment in West. But here's the question I have for you. If you really are putting a column store index on top of this in-memory table, it has to be impacting some level of performance, would be my guess.
Well, exactly. And I think, we'll sort of jump into SSMS over here and sort of take a look. You're right. I mean, the key innovation, Sean, in what this thing has done is really address that. You have completely different workload scans. One's doing OLTP and the other doing the column store, operating on the same table, not impacting performance. That is really the key innovation. So let's take a look at what's really happening here. So what I've highlighted here, essentially, is the procedure that's used by this application to monitor the negative sentiment in real time. Now, let me actually turn on, just for the purposes of this demo, let me actually turn on the execution plan and execute this query. And what you'll see here is what we have. Let me just zoom in so it's a little bit more clear. Is that this table, which is your operational store, now has a non-clustered column store index, which is the reason why the analytic queries are actually performing faster.
And it has no impact on the throughput or writes into the system.
Let's say close to 0.
That's awesome. Awesome.
And, and sort of if you really think about it from a DB or a developer point of view, all that you did is create a non-cluster column store index on the table, which is something that you used to. There's no changes to the application, really.
Incredible. That's awesome. Thank you.
Thank you.
All right, there's demo number 1. Now, if we come back over, and really I think the big key takeaway here is you put a column store index on top of that in-memory table, and off you go. You want to be more competitive? My hunch is what you're going to find is these embracing data in real time and getting after a scenario like fraud detection is one thing, and there are many, many others in between. So let's look at another big investment here. This one's a lot of fun. So when you look at security, front and center topic, there's 2 or 3 things almost everybody's going to talk about straight away. What's number 1? TDE. Why? I have encrypted data on disk, and if somebody steals that disk, I don't want them to be able to do anything with the data. Okay, so there's TDE. Then there's role-level security. I want to implement RLS so that at a user level, authenticating into the system, I can filter the data that I return back. Number 3 is data masking. I have a developer environment, somebody's pulling up PII data or like credit card number. I want to mask that in the client so you can only see last 4 of social. Now, in all of that, there is one major gap. That's the data being not encrypted or unencrypted when it's in motion. This is where these man-in-the-middle attacks begin. Everybody's like, hey, you can have TDE, you can have RLS, you can have auditing, you can have data masking, but as soon as that data flies across the wire, I'm going to snatch it and thank you. That's all until always encrypted shows up. The solution sort of works like this. Always encrypted is about literally always encrypting that data throughout the entire stream while it's in motion. When you put these things together, it's pretty awesome. But here's the idea. You have SQL Server, and the lower right corner is just a simple table. The first thing you'll do using this enhanced ADO.NET library is you'll encrypt the data on SQL Server, on that table, this particular column. And one of the first concepts to grok here is when you encrypt that SSN column, basically what's happening is the data is being replaced with ciphertext. Okay? So that's concept number one. Now the next nice part is, hey, where's the master key held in all of this? Not on SQL Server. It's held on the left-hand side here at the client. So when a trusted client with that key queries for, in this case, we're looking for a select for a name with that particular, that equals that social security number, that client basically then communicates with SQL Server. SQL Server, in return, retrieves that row. It's basically processing or querying that ciphertext, and then it returns the result set back to the client that is decrypted on the fly. And that's how the concept works. I love this one because it fills a giant gap in the industry. We started this research a few years ago, but we really, really are committed to not just auditing, TDE, data masking. Those are all great things, but that data in motion is where people are most vulnerable. So if I ask Rohan to come back up, and let's have a look at always encrypted in action. So go to number 1.
All right. So if you remember, the place where we left off the last demo was Terry Adams was essentially concerned that, hey, I've seen the spike in negative sentiment. So so he has to now sort of dig in and understand if this is really a genuine scenario of fraud. So let's actually click on, the patients at risk. This is again the front end of the application. And what you'll see here is basically a table that's sort of joining the social security number of the patients who sort of complained about the drug causing the negative sentiment with the name, and sort of it's getting demonstrated for him to sort of dig in and start looking.
Right. So I see everything in this client like this because it's been decrypted.
Yes.
But what does this actually look like on SQL?
Let's go take a look, right? So obviously we are sort of looking at this in the app in the clear text, but let's actually go take a look and see what is really happening behind the scenes. So this query essentially goes and sort of lists out all the rows in this table as seen on the server side. Now if I execute this, one of the things that you'll notice, Sean, is the schema of this table is very similar to what was being shown in the application. The only difference being...
All right. But, hold on. Nice trick. This is data just sitting on disk.
Yeah.
Yeah, TDE can do this, boss.
Oh.
Yeah.
Oh, yeah, that's
not
right.
So awesome at this point.
All right. All right. Okay, it's not done yet. It's not done yet. So let's go back. Let's go back to the application. And here's where the magic comes.
Okay. Are
you guys ready? So I've actually enabled Profiler sort of on this app, sort of monitoring the backend. Let's see what happens when I click on the social security number.
Awesome.
All right? There's a query that's just gone in that sort of brought up this patient's record. Now let's go take a look at what the Profiler captured. Right, sorry. Do you see this? This is basically capturing the network traffic that's going back and forth from the client. And look at what SSN is. Is this what you actually see?
That's awesome. So in this case, there's a perfect example of identity theft. If I was in the middle of the wire and you were passing all that patient information, I could snatch that off the wire.
Absolutely.
Thanks, I just stole somebody's identity. But with always encrypted, I think what you're just showing here is what I would have got is that.
Exactly, and this is really the unique differentiator when you think about TDE and always encrypted.
Absolutely.
TDE guards your data on the disk, right? But as soon as the data is read out of the disk, even if you've encrypted it, in the SQL's buffer pool on the network, it's all in the clear text. As like Sean was saying, that's where the man-in-the-middle attack comes. Now with always encrypted, the only place where the data gets decrypted is on the client, because that's, and when you think about the cloud as an example, right, where you're worried about it, what's the worst that could happen? People just steal and get a bunch of encrypted
encrypted data they can do nothing with.
Right.
Okay, so let's ask this next question then. What about a data? I already have a database with data. Like, how does this thing work? Is this only new apps, or what if I wanted to just apply this to a current app?
It's a great point, and this is where we sort of thought a lot about it from a scenario standpoint. Enabling existing applications and existing data is very, very critical going in, because that's given just the install base of SQL Server. So let's go back to Management Studio for a second. And here's what I'm going to sort of demonstrate, right? So we have two tables that we've created. The first one, which is customer plain text, essentially has all the customer data that's stored in plain text. And we have another table called customer encrypted, which essentially is the same schema, the only difference being that one of the columns is social security number, and that social security number in customer encrypted is marked as always encrypted. That's the only difference. The rest of the stuff is exactly the same. And then let's go take a look, right? So when I sort of run this query, you basically see that the social security number is in clear text, right? And then you have, Bill, Ted, Brian, Connor, a bunch of these names. Just, for the purpose of the demo, we should remember that. Now, in my table with the always encrypted column for social security number, right? And now, other than the schema, essentially, if you go take a look, you essentially have the same information that sort of is encrypted. And the way I got to this point, from the plain text table to the table where this thing was encrypted, is by using a very simple SSIS package, right? I just basically executed this SSIS package, and what it did, it basically got the data onto the client, realized from the table metadata that this particular column, social security column on the encrypted table, has to be encrypted using always encrypted, use the encrypted algorithms on the client, and put that data back on the server. So as far as, and all the logic, like you explained, is in the ADO.NET client drivers, the other client drivers that we have, and the app for both of them was exactly the same.
Awesome.
Like all the innovations happening underneath the covers.
Awesome. Good stuff. Thank you. All right. So there's always encrypted. Let's see here. So the thing that's awesome about always encrypted is, as Satya is constantly talking about new innovation, this is another example of in the cloud. You're able to iterate on these designs and the invention that you can get to quickly. This is a great example of it, and we're really proud of being able to stand together with you and know that we really are committed to data security. Now, if we summarize, I wish we had a lot of time here, and I want to get through the whole release. But if you summarize mission critical, some of the other investments that we're making, operational analytics is great. In terms of in-memory OLTP, we're expanding the programming surface. I think one of the fan favorites is the query data store. You upgrade, there's no more planned regression. Pretty much every time we introduce this to people, any DBA that's been in the trenches loves this because you can upgrade with confidence and you're not going to have query plans regressing. We'll add native JSON support, temporal database support. On the security front, you'll have always encrypted that we just looked at, role-level security, which you've been asking for. It's already available in SQLDB, and dynamic data masking. And then on the availability front, one of my favorites to highlight here, if you're using Always On, we've heard from you, especially if you're trying to do read scale and you have all these secondaries. The last thing you want to do is manage a bunch of client connection streams to each of those. But we'll introduce a round-robin load balancing for replicas. It's very, very, very cool. And then lastly, on the scalability front, SQL Server 2016 will take full support of Windows Server 2016. And you think of something like 12 terabyte memory support and how fast you can build a system. It's incredible. So there's a tremendous amount of work going into that mission-critical front. Now, if we switch gears, and now let's talk about deeper insights across data. So the very first thing we like to sort of highlight here, like when we're really chatting behind the scenes about this, we've heard you loud and clear. We need more in this area and SQL Server 2016. We need a ton more. Here's one of the first big asks we've heard from you. Bring Polybase to SQL Server, right? And that's exactly what we're doing. Why? These are the types of scenarios customers are doing. You think of in the insurance industry, somebody wants to do this tailored claim system. Basically, you put a sensor in your car, you drive around, the car collects telemetry on how fast you're driving, if it's in accordance with the law or not. And then on the flip side, what they want to do is incent you to drive better so that they can give you a better rate. And then the way that really works, if you think about it, is you have sensors in cars. They'll start off with one car, will go to 10. Before you know it, it'll be millions. These cars are emitting telemetry into Hadoop. And then once that telemetry is there, what I really want to do is join that with customer records. So for example, I want to write a query. Let me look at Rohan Kumar's driving over the past month to see what it looks like. Here's how it would work with Polybase. One, we'd introduce this notion of an external table That external table will allow you to leverage your T-SQL expertise, basically to write a simple query that would say, hey, show me Rohan Kumar and his driving history over the past month, so I can ultimately deliver a very tailored policy just for him. In order to do that, you need all these parts that we just sort of covered, but this is a big, big, big technology thing that we worked on a few years ago. It was only available in our APS, our analytics platform system, our on-premise appliance, and in 2016, it will be available to you in the box. Now, another big investment for us in this area is advanced analytics. How many people here saw the acquisition of Revolution Analytics? A number of us. So let me just sort of give you some context what we're planning to do. Basically, the simplest way to think about this is we're adding a fourth workload to SQL Server 2016. What's it called? Advanced Analytics. What's behind it? This is it. Think about the scenario of in-memory OLTP. When we built in-memory OLTP, we did not ask you to go buy separate hardware, buy separate software, set it all up. That's not how we do things. What we did with in-memory OLTP is basically introduced it to you as a feature. You turn it on and you get the benefit. We're going to do the same thing here. What do I really mean by that? Is what we're really doing is taking that R runtime and integrating it with SQL Server. So it's hosted with that process. And that means you don't have to go out and buy separate gear and separate software. You basically turn this feature on. When you turn that feature on, something like R gets instant benefit of SQL Server. Ease of use on setup, instant HA, all of the security. It's incredible. And then when you think of that scenario that we looked at with Rohan, that fraud detection, the real key here is you want those data scientists to be able to run these models over that data where it exists. And that's really bringing compute to the data. In this case, it could be running a sales forecasting model against data on that system. Now, how many people here have data scientists in your organizations? Very few of us. Pretty normal. I've only had one person raise their hand and say I have 30. In a forum like this, it's pretty normal. But this is why this other part of the story is so important. In Azure, we have an Azure ML marketplace. And basically, you can go to this marketplace, and if you're not a data scientist, if you don't have data scientists in your company, but you hear things like, hey, predictive maintenance, warehouse efficiency, sales forecasting, credit risk. Yeah, I'd love to try that out. Instead of having to find a data scientist, what you can at least do is go to this marketplace. You can find these models where scientists are sharing them with everybody. Here's the super cool thing. You can take one of those models, for example, and from Azure ML, you can add it to your analytic library on SQL Server, and then you can start exercising and training that model against your data for something like credit risk protection. So we are incredibly excited to introduce this fourth workload. Why is this important to you? It's a built-in feature, and this is going to allow you to embrace data fully so you can get after more competitive scenarios for your business. Now, here comes a cool, very cool, fun demo. You've been asking for some time, hey, I have users with mobile devices. I need to get mobile BI to my users. From SQL Server 16, I need to get mobile BI to my users. Please, please help. And we are incredibly excited to tell you we believe we're going to have an amazing mobile BI solution for you in 2016. Nothing better than to just show you this for real. We'll have Yvonne join me here, and we'll go through the demo. 7, correct? All right.
Thanks, John. As John mentioned, many of you have asked us for mobile BI capabilities for SQL Server on-premise data. And with the acquisition of DataSend, you can do that. You can create rich visualizations on your on-premises SQL implementations on all mobile platforms. And let's take a look. You introduced FabricCam earlier to us and how they make that work for them and how they can really now track the performance of their organization, their business. And let's take a look. Here, they have actually created a number of visualizations and KPIs that they share with different parts of their business. But you introduced the auto business, the insurance company. So let's take a look how the introduction of the new business that you introduced, the tracking of the driver's behavior, actually works for them. So let's take a look at the visualization, and it's beautiful. As you can see here, we saw earlier, the branding that we used for the previous apps is now showing up here as well. So you can use custom branding. You can make it your own. And you can see here on the top, I have a time navigator, so I can slice the data however I want to. But right now, we're looking at last year. If you look at the map, it doesn't look good. And that's because of the agent business is not doing so well. So if we take a look at traditional agents, people want to do something online, customized service, should be fast. It's looking red. So really not a good place to be in. So as Sean, you mentioned, they introduced this new offering, tracking customers' driving behavior and offer a specific policy. They introduced this about 6 months ago, and if I take a look at this here, still looks kind of red because I'm just looking at the agent, but if I go look at the all-up business, you see the dial is going to the right, that's what we want. And if I look at the tailored business here, this is really taking off. People really like that. But let's take a look a little bit like the detail. What does this really mean? Let's drill down to details here. Now we can see the records. We can really dive deep in what that means. And what we can see is that the agent business really going down. The direct model, where you can go online, doing kind of okay, but there's risk. People tell us anything they want when they put their data in online. But when we look at the tailored business and really track the behavior of the driver, which I believe not everybody might want to have that done, but it works out for Fabricam.
Why are you looking at me when you say...
Oh, that was just random, I don't know.
That was not rehearsed, by the way, so I'm now wondering what is going on, but okay.
Well, it works out for Fabricam, so they actually increase their business. The performance of the business is up, and at the same time, the risk is down. Super important for an insurance organization. Now, but how difficult is it to build a dashboard like that? And we mentioned earlier it's for all platforms, mobile platforms. So let's just create one. Just click here on Create, and now I can start from scratch, or I can use an existing one. Let's do that. I just use the beautiful one that we had in the past, that we used earlier. And you can now here take from existing visualizations and make them and connect them with your data. And you can see here, this is the master layout that I used so far, but there is specific layouts for different form factors, like the tablet or the phone, because we want to make sure that these mobile experiences are perfect, that people like to play with them, that people like to use them. So let's build one for the phone. And I'll just pull this over. You see it's optimized for the space that I have. Then maybe I'll take this dial here. I like this one, especially because when I drag that and give it more space, it actually changes automatically. Beautiful. Now let's take a look at the map. Maybe I want to have the map there. And last but not least, I'll take this one. And you could see that it's all optimized for touch. I didn't touch the mouse at all. And let's see how they will look like for the user. Beautiful experience for it. So they're now ready to use it. They see the data, and it works right from here.
Wow. So you just built a full-blown dashboard. You literally just touched everything on the surface, and that's how it would show up on the phone.
Exactly. And it's fun.
All right, that's good. Thank you so much. That's a great demo.
You're welcome.
That is pretty awesome. So that's when we talk about bringing mobile BI to you in SQL 2016, that's the experience. You can go back to your businesses with confidence. If you have people pressuring you to get a BI experience from your on-premise data, That's how simple it was. That was real. Just in a matter of minutes through touch, we quickly put a dashboard together, and you can only imagine how quickly you could go with something like that. So when we look across the surface area and the investments that we're making here, we talked about Polybase. We are definitely a ton of enhancements that are going into integration services. This notion of how we scale and manage analysis services, taking more advantage of CPU and memory. We have all of our tooling experience is going to show up in SSDT. So everything that you've seen so far, there isn't a separate BI tooling experience. Everything you've seen is going to come inside of SQL Server Data Tools, and it's free. You can go out and grab that Community Edition, and off you go. There are plenty of other enhancements around our data services, but the ones that I really want to call out are here on the right. I just want you to know you can go back with confidence knowing we are very committed to advanced analytics and bringing that into the system. It's going to be built in. If you found in-memory OLTP to be favorable, this is the same thing. You're going to turn it on. If you don't have data scientists in your environment, it's okay. You can start grabbing models up in this Azure ML community location, and you can get started. And if you're going to embrace data, my hunch is you will be the leaders that are making a giant impact in your organizations. And the last thing I want to point out here is reporting services. Reporting services in the box are going to be completely modernized. We think that we'll love that. And I see a few people here smiling. So I think you'll enjoy those investments. Now let's look at this third conversation of hyperscale cloud. Now, one of the things that I want to tell you here while we're here together, I'll tell you the real story of how this came to be. As we were traveling around meeting with customers, this is what the conversation sounds. I'll give you the short version of this. Customers would say things like this: hey, there's leaders in my company, they're not into the cloud, starts with security, but I'm sort of stuck. That's one thing we heard over and over. Then the next thing we'd hear is, gosh, I have these databases with huge history tables, millions of rows, and it's sitting on the most expensive storage in my environment. Man, I wish I could somehow get that into Azure Storage. Why Azure Storage? Because as long as Google, Amazon, and Microsoft keep battling, you're going to win. Storage costs keep going down, 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 so people get attracted to that. And then we were on this flight back, and after meeting a bunch of customers, we're like, gosh, it'd be awesome if you could stretch a database into the cloud. And we went back, we drew it on a whiteboard. A couple people chuckled, because you draw the thing, and this is what I mean about an idea. And we were like, gosh, if you could stretch a database from on-prem to the cloud, then you could potentially solve this problem in a very interesting way. What do I mean? So imagine you have a SQL Server. You have an orders table that's hot, so we're writing data to that, but you have orders history. It's just cold data. It's sitting on that super expensive storage. But what if you could basically go up to that SQL Server, run a simple tool that say, hey, that orders history table is a good candidate, and you just stretch it into Azure. That'd be awesome. Boy, that would be really interesting. Why? Because if I can get all that cold data off my super expensive storage, this is a game changer for me, maybe economically. This is maybe how I get a toe into Azure. Here's the next cool thing. Your apps don't change at all. Any DBA sitting in this room, this is all up to you. You don't have to go back to your app environment. Then we'll show you a demo of this, right? If you decide this is something you want to do, you turn it on, and this is how it works. Your apps, they'll continue to query like they always do. And when that app hits that on-prem SQL Server, that on-prem SQL Server knows where that table is, and it will distribute a query up into Azure. We'll spin up compute. We'll process the data, bring it back down to SQL Server and to the client. It is incredible. Here's the next part of the conversation. A customer, when they usually see this, they'll go, that's awesome. I have never seen anything like that. But hey, remember when I told you when I first sat down with you, security is a concern in our company? Always Encrypted works with this, and it's beautiful. Why? Because when you stretch into Azure and you always encrypt that data, remember always encrypted, and you're managing that key, you have full control. And imagine that data coming across the wire, just as Rohan showed you, it is encrypted all the time. This is why encryption in motion is so, so, so important. But when you talk about StretchDB with always encrypted and RLS and that security, I have literally, and I would tell you this right now, I have sat down with banking customers that are very conservative, and once they see this whole thing, in one conversation, they've completely turned. We need to prototype this right now. They view it as, this is how we get into the cloud. So I'd use that as a backdrop, and then Rohan, why don't you come back up and show us a demo?
So you're super, super excited about StretchDB. And let's go first take a look at what it means to actually enable an instance to stretching. So by default, out of the box, when we spoke to customers, they're super concerned about, hey, if I go get SQL Server 2016, will you just automatically start putting my data in the cloud? Please don't do that. And we said, no. So by default, the feature is disabled. So as a DBA, you have complete control of actually enabling StretchDB on your instance. That's the first thing to keep in mind. So let's go ahead and do that on the instance that we have running here locally, right? So it's a pretty simple sp-configure command that essentially goes, enables this and sets it to 1.
So when I get SQL Server 2016
yes,
and turn the thing on, I get my environment set up. If I want to do stretch, basically what you're saying is by default, the box isn't going to stretch any database.
Yes.
But to turn it on, I simply come here and run this.
That's exactly
and
it.
I'm
So
good to go.
Very simple command. Now, what you've done at this point is you've enabled the instance, the SQL instance, to allow databases to be stretched.
To be stretched.
None of the databases have been stretched yet.
Got it.
Got it? Okay. Now, let's go and actually take a look at how do we stretch a database, right? So here, I've picked a database, FabricAm stretch. And all I need to do is basically right-click, go to the tasks, again, very well known, and you see we've added a new verb which allows you to enable a database for stretch, right?
Yep.
So let's click on that. And before getting into the wizard, one of the things that we've actually focused on as a design point is this feature was designed for DBAs who've not really understood much about the cloud yet. They haven't been experienced it. They haven't been exposed to it. So what you will see as I go through the steps is everything is within, to set this up, is within the tools that they know and love.
Yeah, so if we pause here for a minute, just to give a little color around this, what Rohan is bringing up, a number of customers that we would meet with, he's not kidding. They haven't had any time really, truly, to look at the cloud. And as I remember distinctly when we were talking about this flying back home, we said, hey, if you could stretch the database, that'd be pretty awesome. But the last thing you want to do is have to stop and then figure out what the cloud is. That just isn't gonna, it's not an option.
It's not an option.
Right?
Exactly.
So how does a DBA that knows Management Studio, they know SQL, they like the concept, what do they have to do to stretch a database into the cloud?
Let's go dig in, right? So basically, I picked the verb to go stretch this particular database. I enabled it on the instance, stretch it. Now, the only thing that they have to know, really, because we're sort of, tying this, database that's on-prem to the one in Azure, is have Azure credentials.
For a subscription.
For subscription, exactly, for establishing the subscription relationship. So let's go ahead and do that, and this is where, my heart starts pacing a little bit, because this is all live working on a build that's 2 days old.
It's all right.
Let's try this. So let me enter my Microsoft credentials.
Yeah.
Right, again, let's go take a look.
All right, we should.
It's going to take us to the organization. I mean, for folks who sort of used Azure, Microsoft has enabled two-phase authentication for all their employees. Let me just do it again. Right, so here I'm just basically going ahead and signing in. And it says, sign in with your phone. This is all real, by the way, just to tell you that it's a real card. Now, this call is going to Microsoft. Microsoft's going to call me to make sure I am telling them who I am. This is the two-phase auth. Let's see if the phone rings.
Rohan.
Hello, Microsoft. So I've entered my PIN followed by the pound sign like they asked. Now this should authenticate me.
Oh, that's awesome. Nice.
Right, extremely secure, and the whole thing works end to end. So here I have two subscriptions that are associated with my corporate account. I pick one and basically go, and then again, all this is happening within SSMS. So the wizard essentially asks me to select. So let me just go pick East US2. These are all the regions in Azure
Yep.
where you can basically go stretch your database. So
and if you pause here for a minute, it would be you know, if I'm sitting in Chicago right now and I can at least pick like, hey, I want to stretch to one region over like north, central versus west or something in that sense. Got it.
So basically you pick, because you know it impacts the latency of requests, so you pick the region and then you essentially start, you know, just, you know, creating a server name, essentially the equivalent server instance that's actually in the cloud, and then pick a password, which, you know, they have constraints around what qualifies as a good password. And once you pick that, that's it. The system does everything for you. You have the settings, you know, all that you did was went through the wizard in SSMS, and now the SQL instance is
just
figuring
stretching,
everything out.
I don't have to change any client connection string. So like as we were saying earlier, as a DBA, you have full control. You really do. You turn this on, you can stretch, you can test it out and see. And the reality is the big benefit is I get this cold data off my super expensive storage. Right. I put it up in Azure storage. I get that compute spins up. But is there really truly a distributed query thing that's happening there?
Let's go take a look in terms of, you know, first in the app itself, right? Like the application that we had. We were looking, if you guys remember, sort of paging this back, we were trying to investigate, you know, the fraud part, and, you know, Jennifer was one of the customers who basically had a lot of negative reaction. And specifically, one of the things you'll basically see her once I sort of click the customer is there's a little icon here which actually shows what the location of her records is. Now, if you step back and think about it, over several decades or several years, right, when I'm sort of collecting in the application the patient records, you could imagine, just like your orders history example, those things grow and become a huge, huge database. Like all the records per employee.
Right, and then you could think of things like having to go to tape.
Exactly.
Right?
Exactly. And
like
you know where that goes, right?
It doesn't go. Because like in today's world, if I'm going to embrace data, the last thing I want to do, imagine a customer calls up and says, hey, I applied for a loan 3, 4, 5 years ago.
Yeah.
You don't want to put the person on hold and say, hey, you know, we'll get back to you. You want to pull up an app and say, hey, bam, I see everything that you've done 10, 15, 20 years from now. That's real time. Okay.
Exactly. Basically being able to access even very, very old data without having it untamed. Now here, as you can see, like if I basically just go through the set of pages, you start seeing the icon in the app change. The location of it, essentially the one that, you know, the disk location is something that's actually on-prem, that's warm.
Yep.
And in this particular case, the application designer designed based on time, right? So anything that's 2007 August and older
is moving
has been stretched to the cloud. But like you mentioned, when I issue a query that actually tries to access that data, you're not pulling in tapes, trying to put tapes, figuring it out. It's all in the cloud. So even though it's a little longer, because you have to go to the cloud, it is still warm and it completes in real time.
And so I'll take that trade-off so I don't have to go to tapes. Plus I free up my last thing I want is 10-year-old data sitting on my most expensive storage.
Yes.
I like that, but I really am curious as how this truly works behind the scenes.
Let's see how this thing is actually built behind the scenes. So for that, we basically have this demo where what I've created, Sean, is there are 2 tables with exactly the same data, exactly the same schema, exactly the same data, exactly identical. And I'm going to issue 2 queries. The only difference between the tables is one of them is enabled for stretch.
Yeah.
It sort of goes and it's stretched in Azure, and the other one is not.
Okay.
Now let's take a look at the results that come back and what's really happening behind the scenes. So for this, I basically just go and enable, looking at the actual query plan, did I enable it or disable it? Okay, I just enabled it, right? And let's basically go run this query, which essentially is just trying to get the data of this table, right?
And this is everything's local.
Everything is local now. Essentially, like you have Jennifer, the first few records, she's complaining a lot. There's Joachim, Kedar, Virginia, etc. Now, if you take a look at the execution plan, there's nothing. I mean, you basically see a bunch of nested loop joins, there's a clustered index scan, but everything is happening locally. There is nothing remote or nothing distributed that happened. Now, let's go back and issue the exact same query on the table that has been stretched to Azure, right? Let me essentially go execute this query, right? And let's see what happens. You'll notice, and this is a little subtle, you'll notice that it takes a little longer than the previous query. Oh. Okay.
Oh, you're getting blocked by client IP.
Oh. All right, so, well, what is supposed to happen is that the query was supposed to take a little longer, And if you actually take a look at the execution plan, look, this is all real time, right? This
Yeah,
is
but
the
hold
that's the result.
on. This is a good thing, though. This is by design. And what's happening right here, I'm just looking at this message. That client IP with this address is not allowed to access. So the security on the Azure side is actually
That's a very good point, actually. You know, one of the things about Stretch was we were very, very careful about security. And, you know, obviously there's something going on. But, you know, what was supposed to happen is, you know, you get exactly the same data. It takes slightly longer. And then if you take a look at the execution plan in SSMS, you see a distinct remote query operator.
Right.
Which is essentially the intelligence we've built into SQL Server, where once it realizes that there's a certain amount of data that's remote, it issues a distributed query. And that query, like you said, goes to, spins up the compute, issues the query on the data that's in Azure Blobs,
and
returns
brings
the
that
things
back
back,
down.
joins the results, and actually returns the results back to the application, right? And that's basically the beauty.
That's awesome. So that all by itself is pretty awesome. So now let me ask you this. Imagine, so in my current world, I have this huge table. I'm trying to run backup. I can't. There's too much data. I stretch. This is great, economics of it. But what happens from a backup? How does backup work in this context?
It's a very good question. Like, you know, Sean, like you said, typically Stretch is for databases that have become really, really large, tables that have become really, really large. And you know, backing up these databases is never fun. So let's go and actually see, you know, first let's sort of run a query. You know, one of these patients actually, Jennifer, I guess, sort of went and dropped the table or made it single user logon. Let's see if that works. Okay, good. Somehow the security got all fixed up, which is great. And now let's see how long a restore takes. So at the backside, this table is several gigabytes, you know, like from a volume standpoint. And let's see how long the restore takes, and I'll explain what's really happening in a second. So it's executing the query to restore. It's gigabytes worth of data, and you'll see where if it works right, it needs to come back within like seconds, right? And what's really happening behind the scenes right now is in a stretch table, there is some amount of data that's local, and there is some amount of data. You see it's sort of completed within, well, 7 or 8 seconds, right? If you basically had all this data on-prem without stretching it, and you tried to restore that database, it would have taken you close to 10 minutes.
Wow, that's awesome.
And the reason this was because out in Azure, all that data is as is, right? You basically already have that multi-replicated. You've basically restored the data that's on-prem, and the metadata hookup of the new restored database just connects it back to that instance that's there in Azure. That's it.
Good stuff.
Right? So your backup operations, as an example, become a lot more faster for very high volumes of data.
Perfect. All right, thank you. All right, Mr. Rohan. Yeah, great scenario, great innovation happening there. I'm excited. These are the times I'd love to fly back with you on an airplane, sit down in your own company, and please let us know how much fun you have with this. It's a great, great, great scenario. It really builds on top of some work we've done previous. Stretch tables we talked about. We're bringing Power BI from the cloud, connecting it on-premise into your SQL 2016 environment. We've enhanced backup to Azure. It basically runs much faster. It's more efficient. From a simplicity standpoint, we continue to work on simplifying the wizard and experience around enrolling virtual machines to an on-premise, always-on availability group. And then the last thing I want to talk about here is consistency. You know, we are constantly, I can tell you this, we have a design team. They're thinking about you every day. Their goal is to make sure that regardless of where your data is, on-prem, up in the cloud, that we give you as consistent of an experience as possible. Now, if we turn the page here and really, really think about SQL Server 16 as a whole, let me ask you, what do you guys think? Think it's on track for your business? Awesome. Awesome. And I really like to bring that back to that cloud-first mentality. Over the past few years, I'll be honest with you, I've had people stop me here, and they'll say, hey, you guys are talking about the cloud so much. What about the box? And this is why I really wanted to start with that cloud-first slide, because it's completely transformed our engineering system. And with that, you can not only count on a cloud that's innovative, but from here on out, the fastest and best box releases that you've ever seen to date. And it starts with SQL 2016. So in your own business, if you're getting pressure to embrace data, you need your applications to be more modern, I would encourage you to move into SQL 2016 with a lot of confidence and authority. Now let me show you something else that we've been working on. We've heard loud and clear, hey, in your cloud strategy, where's your data warehouse as a service? And we are excited to introduce, and we will show for the first time ever, a live demo of SQL DW. But one of the things that I would give you some context to is when we were designing Azure SQL Data Warehouse, we were talking to a lot of customers, probably people in this room, folks around the world, and here's what we heard. Folks that have moved into the cloud and using other solutions right now would say things like this to us. They would say, hey, I moved to the cloud because it's supposed to be endless compute and storage. That's good. The economics of the cloud are always supposed to be positive, but I'm not actually having a positive experience. Hey, what do you mean by that? Well, it turns out when you architect a data warehouse as a service in the cloud, boy, is it important to separate storage and compute. Why? Well, basically, from a storage perspective, if you believe Amazon, Google, and Microsoft will continue to battle in the cloud, if you believe that will drive down storage costs, which we see evidence of that every day, then most folks are like, hey, storage, I have a strong belief it's always going to go down. I'm fine paying for my data that's sitting there. The next thing people will say is, but in a data warehousing workload, I don't run compute all the time. I do end of day, end of week, end of month. I do that. I have that kind of workload. Why am I having to pay for compute all of the time? And when you have to pay for compute when you're not using it, that's just not good. That's when these bills don't feel good when you get them. So as a general design principle in SQL Data Warehouse, we are separating storage and compute, so you only pay for compute when you're using it. The second thing we heard from customers, I'll tell you a real story here. Real customer, hey, there's a few times in the year we make a lot of money during the holiday season. And what they do with their data warehouse that's in the cloud is they use it for shopping cart recommendations. So if you were buying clothes from this retailer, you know, you're looking at something you're trying to buy and the list that says, here's other recommendations we'd have for you, that recommendation list was bogging down. It turns out there were so many people shopping that their data warehouse was running out of compute. Here's the story where I couldn't believe this. They said, hey, the cloud is all elastic. We need to add more compute. When we went to add more compute, we had to tear the entire cluster down and build it back up. And that took 19 hours, and that doesn't work. All right, so the true design principle here is if you're going to have a data warehouse as a service, elastic scale should be as simple as moving a slider bar, left to right. You need more compute, move a slider bar. That's what it needs to be. If you're not using compute, pause it. Right? That kind of gives you two fundamental things that we heard. The third thing we heard from customers is, yes, it's awesome that we can set up a data warehouse in minutes. I remember the days, I've been doing this for 15, 20 years, and the days of running setup for days and days and days. Yes, I get it, right? You want to be able to provision in the matter of minutes. But the reality, if you're going to embrace data, setting up a cluster is one thing, doing analytics and BI on it is another. And what these customers really said is, you have these great assets with Power BI and Azure ML and Azure Data Framework, and please tell me they are integrated directly in SQL Data Warehouse, of which is a core design principle for us. So let me show you a quick video of Azure SQL DW, then we'll look at a demo.
Imagine, how could you make your business more intelligent using data? Where do the digital customers using your services come from? How can you engage them better and improve customer churn? How would discounts affect your inventory and margins? Imagine if you could use data to analyze these questions and intelligently predict outcomes. But each question could take hours, maybe even days, requiring more servers than you have in any on-premise data center. But now, you can use Azure to add unlimited compute power to your questions. Introducing SQL Data Warehouse. The new SQL Data Warehouse service is easy to create and can be launched in minutes. It's the industry's first cloud data warehouse that can grow or shrink to any size in seconds, and which you can use to intelligently answer any question using data. You can easily import data from any data source, with automated data pipelines from Hadoop, NoSQL, and SQL databases, IoT, as well as on-premise applications and systems. Then you can easily create reports against it, as well as visualize it. simply connect Microsoft Power BI to a SQL data warehouse in just seconds. It also unlocks the ability to easily use predictive analytics. Azure Machine Learning can now use petabyte-scale data with applications written in R and Python to analyze customer product recommendations or assess customer churn risk. You can expose machine learning APIs that your apps can call to more intelligently interact with your customers. A data warehouse that can scale up in seconds enables Power BI and Azure Machine Learning to tap into unlimited query power. So you can visualize and explore unlimited scenarios. The power to use data to build intelligent apps has never been greater.
Okay, without further ado, in our last 9 minutes here, Mr. Rohan. Hey, we should give this guy a quick round of applause for all this. All right, you ready?
Let's do it.
This is the first time we have ever demoed this publicly, ever. So where am I going? Number one.
Number one. So let me, at this time, basically, I'm just logging into a VM, which has all the things set up.
Let's see here. So we'll log into this machine, and then from this machine, I think this is actually sitting in our research environment. In this case, there are a couple of things. I think what we do over the next 8 minutes is look at 4 or 5 things. Number one, how quickly we can provision a data warehouse.
That is correct.
Number two, how we can load data into it using the Azure Data Framework. 3 is bringing ML to it for analytics.
Right.
4 is wiring Power BI in so you can see things, right? And then 5 is elasticity.
Exactly. So literally, like what Sean just described, these 5 things is essentially what you saw in the video, right? So let's just get going, right? I mean, so in terms of SQL Data Warehouse is going to be a first-class citizen in Azure. So if you've used Azure, you'd have seen you can go create a VM or create a SQL database, and this experience is exactly the same. It's no different. So let's just get started, right? I click on the Create tab right here in the portal, and essentially, okay. All right. Okay. Let me see if I can sort of.
Sign back. Or here you go.
What's the password?
Can you come up and type it in? Hurry up.
Quickly.
Maybe this was the strategy, so Mr. Usher here could get in the demo. Nice job, Matt.
Nice job. All
Okay.
right. So while this is loading, essentially, I mean, we'll sort of walk through. So the create workflow, you go enter the name of the SQL DW instance that you're going to create, right? So essentially, actually, it sort of takes you, I'll tell you how. So this is the portal you landed in. Let's go quickly hit on Marketplace and essentially search for SQL Data Warehouse. Right? So again, in Azure, you basically get, one of the workflows that you can create. You just click on that. Okay, we sort of...
Hit cancel.
All right, let's cancel over here. And then, you sort of get to the blade. Let me just minimize this. So we're back, right? So let's click the Create tab. All this is sort of work in progress. You're seeing real-life code. That's one of the reasons why some of these things come up, right? So if you click the Create tab, what happens is I just go enter a database name, right?
Yeah.
Pick one. Then, like you were explaining, I just pick what the performance of this is. So it's in units of DWU, and the details of this, we'll talk about, right? So I pick the thing. The server, which again, like in SQLDB's case, it's very similar. You basically go pick one of the servers, say select that. In this case, I pick Japan East, right? And then just basically land up going and creating, right? So when I press create over here, all the machinery starting up of sort of allocating the number of compute instances.
So 2-3 clicks, I start off here, and boom, I have a data warehouse up and running.
Exactly.
Okay, so now how do I integrate data with this?
All right, let's go take a look, right? So we've created the instance, then essentially let's go take a look at, so if you basically go into ADF, again, I've already sort of gone there, The diagram tab essentially lets you look at your ADF workflow. In this particular case, for the pre-provisioned instance that we had,
Yep.
we actually already have. And like it was being explained in the video and what Sean was saying, you can basically have SQL data warehouse instance as the sink or the source of any of these workflows.
Got
so you can
it.
imagine you can start your data from document DB, SQL Server, get that data into SQL DW
And just orchestrate that
via
so
the
it's bringing it
ADF
into
workflow.
DW.
And just to sort of show you that it's real, like if you go pick any of these and essentially try to look at the properties of this thing, you'll realize in this particular case, this is essentially a SQL DW instance that we had all previously created. So
Got it.
very well integrated with ADF.
Okay, so how about ML? Now we want to
Right.
do analytics.
Right. Essentially, if you basically now sort of take a look at Azure ML, one of the things, again, you'll realize is you can essentially bring the compute to the data, like you're sort of explaining. So I could actually have these ML models run on data that's actually being captured in SQL DW. So in this case, you can imagine the reader is essentially getting the data out of SQL DW to run ML models on it. And in this particular case, the data set that we have is essentially looking at all the sales data from the past years to create a demand forecasting model.
Got it.
Using an R script, which is a data model that we pulled out from the Azure ML library that you had explained.
Plugged right on top of it.
Exactly.
Now let's look at Power BI.
Right. So now, based on the model that we've created, let's go take a look at Power BI. Well, we just need to refresh it.
And I
Right.
think the scenario here that we want to show really is, think about retail today. Retailers often, when they go to battle with each other, aligned discounting usually
Right.
shows up during the holiday season, but I know for sure retailers have this particular problem. Let's say you and I are competitors,
Right.
and then all of a sudden you come out with a nationwide 20% off discount.
Yep.
I know retailers today, it can take them up to a month to figure out if they were to match that discount, what it really would mean at a
Exactly.
national level. This is
Exactly.
why you don't see retailers at the same time coming back at each other. But if you and I are competing, if I embrace data, I want to basically understand what a 20% discount would mean to a store, to the nation, or to my national stores, and then being able to exercise that over the compute
Exactly.
is awesome.
So let's take a look at that. It was just given the compute of Azure, we were able to create the instance, load data into Azure ML, create a demand forecasting model, and load that model into Power BI. And what you see here is just like you said, Sean, let's say you're giving a discount of 10% and suddenly a competitor shows up and says, hey, I want to discount 20%. Now you want to basically do an analysis, in this case for a single store, just based on the compute that we picked while creating the instance, and just highlight saying, hey, if I basically go and do a 20% discount in the single store that I have, what's the result? And what you'll notice is the impact to your margins sort of suddenly increase, which makes sense.
Got it.
Right? But your gross sales will grow up because you're selling more. Because people see a
so
higher
this is at a
discount.
store level. But the reality is, if I'm going to embrace data and compete, I need to know what this means, not just for this store, but if I made that discount across the whole country.
Oh man, you really want to do that?
Yeah, what were you?
All right, so let's go and take a look. So what Sean's asking for is the analysis that we did for a single store. He wants to go take a look at for his entire chain countrywide. Now here you notice, here's where one of the key features of SQL DW comes in, our Azure SQL data warehouse, where the compute that I actually had associated with this DW instance, I can actually go double it, right? And from 500, I can actually go and say, increase the amount of compute for this instance to 1,000, and all I need to do after that is just basically go and save. And when I click yes, now this process obviously is going to take, now imagine if you basically had to do this in the real world, this is probably 6 months.
Yeah.
Purchasing more hardware, setting it up.
Or in the so an on-premise data warehouse, look, I don't want to order hardware and even deal with that. I can't even respond to a competitor. But in the cloud, this is not tearing down the environment and building up. This is really, truly, you just doubled the compute.
Right.
But what's really happening underneath the cover?
That's actually an interesting question. And this is where the design, the architecture that we've come up with truly differentiates us from what already exists there, where it wasn't just in the business model, even in the design, we basically completely separated the compute from storage. And as you know, that when you're doing analysis, warehouse data is very highly partitioned. So now when I went and increased the amount of compute power, which spins up more nodes in Azure, I can take the highly partitioned data set and spread it across a larger compute. It's very easy. The data is already partitioned. Instead of having 3 partitions on a single compute node, I could say spread it across 3 of them. That's exactly what's happening in the background right now. It's creating that for you. Now imagine if you had to do something like this on-prem, it would just be really hard. Now, it's success, like you guys noticed. Imagine I doubled the amount of compute for my DW instance, and within 57, 58 seconds, it came back and set this up.
That's
seriously,
awesome.
This is highly differentiating.
All right, and then let's look at that last Power PI view and wrap it up.
Right, now if you go back, let me just go and this should, fingers crossed, this should work. I'm going to scale up the Power BI to sort of start taking a look at all the stores as Sean asked for. So let me just go clear the filter. And it's working. It's leveraging the higher compute that we had created. And now you see all the stores have essentially showed up. So
Good
instead
man.
of the one dot,
That's
all the
awesome.
stores.
Thank you. Hey, that's embracing data. This is all real. None of this is faked out. So that's how quickly you can use that compute store, double your compute, use it, get a view like this, etc. So the last thing I want to really say to you is, boy, thank you. We appreciate all of your time. I really honestly stand here today more excited than ever. I've been 20 years in enterprise and now cloud software. And hopefully you leave this session inspired and confident that you truly have the tools and the data platform to go back into your businesses and move them to the next level. So thank you very much. You can sign up for a preview for SQL Server. A community technology preview is going to come out this summer. You can also sign up for our SQL Data Warehouse preview at the link there, and we appreciate your time. Thank you.